Here we go, screen one. Cool. If someone could just shout if it is up and everything's fine, you can see like the Unity page, that would be good too. Okay, cool. So here I've created like this 3D game, and all we're going to be doing in the inspector is basically having these three components. Like the camera and the light is just like the default things that you would have if you created a blank 3D game. And then I added an empty game manager object. So it's just an empty game object that I've attached a game manager script to, and I'll explain what that does in a little bit. So when I play this game or run it, all it does is it generates this like grid. And the colors are specific because that's regarding what we're going to be doing today. So you can see there's literally nothing in the game until I run the game, and then it all gets generated during runtime. So you can see now in the hierarchy here we have all these cloned cubes, which are basically my grid world that I've generated. So you can see it there, right? So these are just cubes that I algorithmically place in the world. Cool. So the reason I'm doing this is because moving forward we're going to be generating some like legitimate procedural content, as well as I wanted to do an example with you guys where we made a nav mesh dynamically, so after or during runtime. So last week we looked at nav meshes that we built beforehand, and we like assigned different area costs and stuff like that so we could get different behaviors. Well, this is going to lead up to next week or the week after a game where we've done that dynamically. So if you can think of it, these colors are basically going to represent our like hypothetical move costs. So maybe red is like it costs 3 to move on this square, blue like 1, white 0, something like that, right? And it will be related to like these areas. Okay, so we'll define these at some point. But that's the general idea. And it's all going to be about stitching like the nav mesh for this object together with the nav mesh for this object. But to get there we obviously have to be able to do all this other stuff beforehand, like reading information from a text file, generating this world, etc. Okay. So the first thing that I did when I made this was, in order to have all those cubes, I have to create like a prefab for it. So all I did was made a prefab folder, and I created a cube here. So in the hierarchy I just said create 3D object cube, and then I like to find its size and stuff like that to be something that I want. What am I doing? Here we go. So I defined it like, to be some size, and then you can drag and you drop it. Sorry, you drag it from the hierarchy and you drop it in, and then that's how we created a prefabs. So we've done prefabs before, so it's a little bit of a reiteration. Okay, so I created a prefab, and I also created a couple different materials. And again, this is just how I've been making the materials beforehand, nothing too fancy. I created like this red and this blue and this white material. And again, that's just from right-clicking, create material, and then like changing the color to be something, something you want, right? Cool. So actually, let me just make this like a brownie color and rename it to 3, and we'll use that in our thing. Okay, so that is basically everything that happens within, say, like the UI or the user interface. Everything else is going to be based on code and in like a text file. So in terms of text file, we want to create this text file which represents the world that we want to generate. So whenever you want to like include external files, you need to put them in this resources folder. And that's usually so that when you build the project, like you final build the project, this resource folder is attached to your game. So you can actually read this information in. So it's just, this resources is like a keyword, so it has to be like the same spelling, etc. So you can actually use it. And in there I have created this, this text file, and I've opened it, okay, obviously in Visual Studio, but it basically, on the first line of the text file, it has the number of rows or columns, I can't remember, and then the second line is also the number of rows or columns. And then the rest of it is just the actual world. And the numbers are basically going to represent what type of terrain. So if you've done like a little bit of the snake project, perhaps you've done that. If not, you would have been dealing with like text files like this that tell you, okay, the snake is in XYZ or XY position and stuff like that. So it's basically running in a similar type of stride as that. So everyone understands this text file. What it does, it just represents my 5x5 world, and the size is indicated by the first two rows. Cool. I think that should be pretty straightforward for everyone. So now what I'm going to do is I'm going to show you, when I press the play button, that my game manager script will initialize that world. So all I did here was I made a code folder, created a script, called it game manager. I think game manager is like a fancy keyword as well. That's why it's got this weird symbol. I'm not 100% sure. I was surprised when that happened myself. And then secondly, I've created this tile class. So I'm going to show you how those two work. But firstly, so we have the data, which is in the text file. We need to actually load that in so that it can be utilized. So in my game manager, I've got this function called read world data. So I'm just going to remove that quick, and we're going to go through it together. Cool. So my game manager is a classic like script that you would create. I haven't removed anything or added anything in particular. It still has like your start and your update functions. However, I don't use them, so I can actually remove these. And what I've done is I've added the awake function. So in like the chain of processing events, awake happens before start. Okay, so start is like a special function that gets run when it's trying to handle all the start functions. And awake is essentially another function that works exactly the same as start, but it happens before start. So it's very good to do initializations and stuff like that in awake, and then you can do some other stuff in start if need be. So that's why I've created this function called private void awake. It could be public. You could maybe not even have this identifier here as well. It would still be fine. Cool. So in order to load text from a file, we obviously need the path. So you can see here I've included that resources folder. So your default folder is assets, and then you go resources, and then the name of the file, and then the format. And this name, you can see I'm receiving it as a variable, and I've done public string world name. So here we can see two different types of doing the same thing. So I have a public, so this means I can set it in the inspector or in the Unity interface. So if I go there now, quick, click on my object, you can see world names there. And then the other way I did it was with like a serialized field, and you can see that's also there. So we want the name of the file, and you could have just hard-coded this in here and then change it every time, or you can maybe have it as a variable so that you load different worlds depending on something, I don't know. And once we've got the path, then we can read the world data with that path. So how do we actually read information? Well, there is a nice like a set of libraries, or a nice library, which is, I think it's using system.io, and that allows us to make use of a structure called reader or stream reader. If you guys are slightly familiar with like maybe Java, it utilizes the exact same thing. So it's just basically a class that allows you to well, a class that has some functions that allows you to read data from text files. So what I'm going to do is add a stream reader object and call it reader. And this thing wouldn't have popped up if you hadn't included the system.io. So that's how you know if you're doing it right or not. And if you Google some of these things like how to read text from a file, this is going to be like one of those solutions that you'll see. And usually they'll tell you what things you need to include up here. Okay, so we're going to define this as a new stream reader, and we're going to feed in the path. So if you guys should know this, but when I say new and then stream reader, I'm basically making an instance of this class, and that is called reader. And this is basically a constructor, right? And the constructor for stream reader requires a path variable as part of its input, right? And our path is where that text file is. So it's going to read the text file or read from the text file. Cool. So now this stream reader has functions like read line that we're going to make use of. It also has like I think read character or just read the next variable, something like that. There's quite a few different ones. But for our case, because we've set up the text file in a specific way, we can say rows is equal to reader.readline. And you can see all the other ones like read block, etc., read to end, if you want to just read the entire thing. Okay, so now the issue with this is readline returns what? There, you can see it returns a string. So we've got to convert string to int. And we can do that by saying convert dot to and then int, yeah, it's there, to int 32, and encapsulate this. Okay, and then this convert like library is within this well, this convert function and object is within this library here, this using system one. And again, how did I figure that out? Well, I didn't know. So I was like, okay, I have a string, I need to save it as an integer, and you just Google string to int Unity or string to int C#, and you'll get lots of different solutions, and this is the one I used. Cool. So we have the rows, and this is just a variable I declared up here. So we have the rows, and let's just do the same thing for the columns. Cool. And now we have the dimensions of our world. So all we now need to do is basically loop through the rest of those characters in the text file and then store them to be utilized in some meaningful way. Okay, so what I like to do is just store my my text files in like a char array, just as like a secondary like a storage location, and I'm going to show you how to do that quickly. If I remember quickly, it's just char, and then I called it char world. Char world, and that is going to equal to a new. So this is an array, a 2D array, and you know arrays need sizes, and we have those sizes now. So what we can do is we can say rows, comma, cols. Now this is something I wasn't too, what did I do wrong here? Oh, sorry, it's not a char, it's the other one. So this is something I wasn't sure that would work, and I didn't know how to do like a multi-dimensional array declaration in C#. So here you can see something that you would maybe be more familiar with is saying something like char like that, right? And now I know it's a, just call it C. And now I know it's a 2D char array called C, right? This might be something you're a little bit more familiar with. But how Unity or C# works is you just put a comma. So instead of having these double brackets, it's just with a comma in between. So indicating there's like a parameter that goes here and a parameter that goes here. And what you would have seen here is that I have this 2D char world array. So that's a 2D array of chars or characters. And I've also got this 2D world array of tiles. Now I've created a tile class that is going to store all the meaningful information regarding my world. It's also going to be where I'm going to store the game objects themselves. But we'll get into that. So firstly here I've initialized my char world array to be of size row, comma, columns. And then you can see this comma thing is coming again here. So maybe you guys are more familiar with something like this, where it's like square bracket open rows, square bracket closed, and then you do the same for the columns. In Unity or C# you can do it like this. Okay. And what I'm going to also do now is initialize my other array, the world one. So it's going to be world, and once again you're doing the exact same thing. New tile rows, comma, cols. Semicolon, sorry. So now I have this data structure here that stores all the characters that represent my world, and I have this tile structure that will store each tile in an array, a two-dimensional array. Okay, so the last thing that we have to do is just simply do that looping, right? And we can loop with a for loop because we know the dimensions at which we need to iterate through. We know it's rows and then the columns, we know that size, so we can use those variables to make things a lot more efficient instead of having to use like a while loop while you like looping until the end of the file or something like that. Okay, so I'm doing for int z equals 0, z less than rows, z plus plus, just your classic for loop. And the reason I'm using z is that if I go into Unity here and look at my actual, I deleted everything. Okay, so don't worry about that. The way I had it was that I had this top-down view perspective, and like my up and down was on my x and my left and right was on my z. So it wasn't x and y. So that's why I've specifically chosen to use z as like my iterator variable, just so I can keep track of, okay, which dimension am I actually talking about. Obviously you guys are aware I could have put like literally anything for these variable names as long as I'm consistent throughout. Okay. And then we'll do like the inner loop for the columns. So for int and then it's x equals 0, comma x less than cols, comma x plus plus. Again, just your typical loop. And we're going to use this to loop through our entire text file, which is, yeah. So it's 5 across and 5 down, so two-dimensional loop that goes 5 and 5, which is what we got here. Okay. Now, the one issue we have is that I only want to use this readline function. So I'm only going to read lines 5 times, and then after that I need to iterate through that line. So what I'm going to do is say char array, and this is going to store like a temp, like the line, like each line at a time. So we're going to say that this is equal to reader.readline. Cool. But once again, you remember reader.readline returns a string, not a char array. So what you can do is strings have these nice functions that you can utilize called .toCharArray. So that solves all of those problems quite nicely. And boom, there you go. Now, the one thing to note here is like when I was converting string to int here, I did everything in the front, right? Well, that's because this convert.toInt32 function takes in the string as an input. But here, the string class, which is what you're actually working with, has this function built into it. So that's why it's .toCharArray and not like toCharArray with this as an input. Okay. Hopefully that clears that up. Maybe perhaps you weren't even confused about that anyway. Okay, so now we just need to iterate through a line array, but we know the length is going to be 5 anyway because of this variable, so we don't have to like find the length of this. And what we're going to say is char, what's it called, char world, and then the index. So now the index will be z, comma x. Again, you might be used to indexing like this. Well, you just take this out and you put the comma. And then this is equal to line array at position x. So remember, this tells us the row, and now we want to iterate through the row, so we basically just iterating through this. So that's why it's just like line array x, and there's no like z component, because over here we basically got that z component. And then semicolon. Awesome. So when this finishes now, we have basically our text file loaded into this array. So I think I can debug this and just debug.log, and then you can see it here. And I'll add, so what I'm doing now is adding a breakpoint, and then I'm going to use the built-in debug functionality, and then I'm going to loop through this, and then I'm going to show you the variable inspector, which yeah, that's fine. Okay, going to Unity. So what you do is you add some breakpoints so that when it comes into this code, and then it'll stop here, and then you go attach to Unity. This is usually set up by default, but you might have to Google like how to set up debugging with Microsoft Visual Studio and Unity, something like that. For me, I don't remember setting anything up. So yeah, and then you run your game, and then it should eject you. Yeah. So it ran the game, and then it popped me out at my breakpoint. And what's cool now is that I have all this information to use. So inside this, I have all the data objects that have been created and their current variables. So I can essentially view what the values are for all of my code, or for all of my variables and all my objects at a particular time. So like cols, you can see cols here, oh, it's 5. Rows is 5. And that's because I broke over here, so that's after this function, right? And now I go to char world, and I can see, oh, it's got all those variables stored in them. So you can see that's all good, and you can double check that that's correct. Now what we could have also done is I could have put a breakpoint here, and I'm going to do that. And I just press the square to stop, and now I'm going to attach again. And I go, sorry, I stop, and then I need to stop running inside Unity as well. Go back into Visual Studio, attach it. Okay, it's currently setting everything up, and it's ready. Okay, and now I start running, and now look, it broke me over here. So now I can do stuff like step over. So if you've ever done anything like debugging before, this is how you can do it for Unity. I can say step over, and then it executed that line. And then I can say step over again and executed that line. So right now if I go here, rows should be 5, which it is, and columns is -1, which is what I initialized it to. So this is really, really useful for debugging. And you can see char world is null because we haven't done anything with it. I've just declared it here. And if I had to like try access a variable like char world x00, it would return a segmentation fault because, or a null pointer reference error because it's a null, right? So then I can just start looping through it one at a time. And now because I've initialized my char world, it's here. But it also has just like end characters. The /0 I think is pretty just like an end line character or something like that anyway. And that's just whatever the default initialization stuff is inside this constructor. So then I can start looping over things iteratively. And now I've looped over linear array or line array, and it says that it is 0, 1, 0, 0, 0, which is correct. And you can basically loop through your entire program and it updates things. You can see this has been updating here. Now my child world is also updated. You see that one's now 0, that one's 1. Yep, cool. So that's how you can debug. Pretty straightforward stuff. But what we know now is this child world is ready to go. It's exactly what we need. Okay, so we have a way of reading information from a text file and storing it in some sort of structure that we want. But we don't exactly just want this structure. We want something that has a lot more things in it. And that's where our tile class comes in. So what I'm going to do is actually just make one from scratch and call it tile2. So I'm going to say create C# script, and I'm going to call it tile2. And I am going to open, I'm still running the game, I need to close that. And I'm going to open it. Okay, and then like I said, this once again would be the default script that you would get. This would be everything that's in there originally. And what I'm going to do is just delete all of that because we don't need it. You see this class, inherits from mono behavior, which is like a Unity thing, but we don't need that, right? We're just going to make our own standalone class. So I'm actually just going to leave it to there. So public class tile2. That's it. It still has these, which I don't know if they're all necessary, but I just left them, so it doesn't matter. And now we're going to make a tile class. So this tile class is going to keep all the information that's relevant to a specific tile, like in the world, right? That cube, it's going to keep all the information specific to that. And later on, this is going to include the navigation mesh. But at the moment, it's just going to be the mesh renderer, which is what we can use to change the material that's attached to it. The game object itself, as well as its X and Z coordinate position. So those are the things I want on it. So whenever you're declaring a class, so we're going to just start adding variables that belong to this class. So the first one's going to be the game object, and it's going to be the tile. So the actual tile itself within the game world. Next one's going to be the mesh renderer. I'm going to call this mesh renderer. And this will be the mesh renderer component that is on the game object, just so I can easily get it whenever I need to. Int x, just an integer variable. Int z, another integer variable. So now what we need to do is, in order to create a class, or like to create an instance of a class, which is basically, where's an example of when we, so like here when you use like the new, we're creating an instance of the stream reader class called reader. So we basically going to be defining this new constructor variable, this constructor function ourselves for this tile object. So what we do is we just say public, the name of the class, so it will be called, it's tile2, and that is your constructor. Alright, it's basically just the name of the class itself, and it will take in some input variables, or it doesn't. It depends on like what you need it for. The input variables we're going to want is a game object. I'm going to call it T, so this is going to be the tile. So when we want to create a tile instance, we want to have a game object that represents that tile. We want the int x value. We want the int z value. Now these variables could be the same names as these. I just like to keep them different, so when I'm doing the assignment over here, it's obvious which one's which. And then the last one is it's going to take in some material and call it M. Now this material, if you remember when I actually played the game in the beginning, you saw all those squares and they had different colors, and those colors were dependent on the material that I fed in. So what we can do here is now do our initialization. So our constructor is used to initialize our variables. So it takes in these variables, and it sets them to be these variables. Or it sets these variables, sorry, to be whatever it takes in the constructor. So tile is going to be equal to t. Mesh renderer is going to be, this one's slightly more complicated. So it's going to be equal to t. Now t is a game object, and if you remember back to our prefab, t is basically going to be this prefab, right? And you can see it has a mesh renderer attached to it. So this is a component as well as a collider and a transform. So we're going to get this component and get the renderer from that. So what do we say? We say whenever we want to get a component, well, we say get component, right? And then we give it the type that component is. And if you're confused which type it is, well, it says mesh renderer, so that should be a given that it's the mesh renderer. So we just go mesh, and you see it pops up with mesh renderer, and then open close bracket. Cool. So now we have the mesh renderer component. This is exactly what I've done before for different things, but just so you know again. And now we're going to say x is equal to xval, z is equal to zval, and m is going to be utilized to set the material of the mesh renderer. So how do we do that? Well, we say mesh renderer dot material, and that is equal to m. And if you're unsure how I figured that out, well, I just googled how to change a material, and it told me that you take the mesh renderer and you say dot material and you equate it to some other material, and boom, there you go. Cool. So now, again, if you guys are familiar with like OOP, which is object-oriented programming, which is what we're doing here with classes, you might remember like get and set functions. So we're going to just do one example of one, and that's going to be public get tile. And what game object, what type is tile? Well, it's a game object. So it's going to be public game object get tile, and that obviously doesn't need to take anything in, so we won't give it anything, and it's going to return, well, it's going to return tile, because that is what we want it to return, this variable here. And that is our entire class. So what is a class? Well, it's basically like a more complicated or advanced variable. So like an integer, it's basically a class. It has some variables attached to it, which are these, and some functions. So it's a dynamic variable or something that you create. Cool. Save that. And now let's actually use it to do something. So now instead of tile, we're going to use tile2. Tile2. And what's cool is you don't have to do anything like linking, like how does it know this tile2 variable exists or class exists. You don't have to worry about that. And I'm not 100% sure why you don't have to like tell it, but I think it's because it's within the assets. I think just within the assets folder it will find this class. I don't think they have to be in specifically the same folder themselves, just within the assets folder. I think that's how it works anyway. I'm not sure. I didn't look it up. Okay. So now we have a class. So each like value in this array is going to be of type tile2. So at each point in this array, so if I give it like an x and z value, it's going to return an object that has all of these variables that we can utilize as well as these functions. That's how, in general, classes work. Okay, so we have the information from a text file. We have a nice class to store them in. And now all we have to do is basically utilize that class and create our world. So if you remember back to our class constructor, it was something like this, right? And it had a game object that it needed, two integer variables, and you can see it pops up, right? So it needs to take in a game object, an integer, and a material. So whenever we create new tiles now, we're going to have to give it that information. So let's get that information. So firstly, the tile itself. Well, that's basically just this prefab here. And I just used serialized field to get it in the inspector, and I dragged and I dropped it in, and there we go. And I'll show you an example of that again with materials. So now we say game object, and we're going to call it temp tile. It could be called whatever you want. And this is going to be our actual game object that we create with tile prefab, because tile prefab, right, it's not actually here, right? It's not in the hierarchy. It's not a thing that's in my game. But I need to obviously create things in my game. So that's what we're going to do in this line here. So how do you create things? Well, we've done this with the ball game before. We can just say Unity engine. Actually, I won't say Unity engine because I want to show you the error that pops up. We can say object dot instantiate. Okay, there we go. So usually you would say object dot instantiate, and the instantiate function would pop up. But because we're using system for something else, I can't remember exactly, I think it was for this conversion, system also has an object, like an object class. You can see here it says class system.object. And now it's even giving you the solution to the issue. It's saying object is an ambiguous reference between unity.object and class or system.object. It doesn't know which one's which, right? So I don't know if I go through potential fixes. Yeah, okay. It even tells you instead of having object.instance, you say Unity engine, and boom. So that's a little error that I found to be a little annoying because I didn't know how to fix it until I googled. And where we would usually say object.instantiate and then give it an object, well, it's just Unity engine.object.instantiate, and you give it the object, which is going to be our tile prefab. Okay. And we need to say what type that we want to instantiate it as. So we say as and then game object. Again, I don't know how necessary this is. I think it might just figure it out for you. But it doesn't not work when you put this in, so may as well just put it in. Okay. So now at this point we've created an object, but we haven't defined its position in the world. It's just somewhere. I actually have no idea where it is. If we run the game, maybe now I could show you, but I think it's pointless because we have to set it anyway. So what I'm going to do is I'm going to give it a vector 3, or I'm going to create a vector 3, which is our three-dimensional vector, so it has an XYZ, just like our game objects have XYZs, right? I'm going to call it initial position, and now I'm going to say new vector 3. Again, I'm instantiating an object of type vector 3. And again, this needs to take in an XYZ. So what I'm going to do is I'm going to say x, 0, z. So that's kind of interesting. Oh, not z, x. So now I've created this vector 3 called initial position with these variables. And these variables are dependent on like where I am in processing my array. So they'll change, right? Dependent on like the indexes essentially. And that is how I'm going to get the different positions in my world for my grid. And that's how I can also get it to be like perfectly uniform. Because it's the positions are changing based on these variables. Yeah. So now all I have to do is set my temp tile position to be this position. So temp tile is going dot transform dot position is equal to initial position or init position. Cool. So again, if you want to change the position of an object, well, these objects, so if I just go to the game manager here, it has a transform. where is the XYZ component located? Well, it's on the position. Okay, well, rotation and scale have X, Y, and Z, but we're trying to do position, right? So we're going to change these variables, and it's going to be 1 and 0, then like 2 and 0, and 3 and 0 as it iterates through that loop over and over again. Cool. Okay, now the really cool part is, if you remember to our text file, it had these different variables, right? And these variables are going to indicate to us which material the game object must be assigned with. So how we do that is we can define a little bonus function, and I have it here already. And that's going to say, given a character, so given, say, like 0, because it will be in the form of a character, take that character, get the numerical value of that character, so that's why it's char.get numeric value, and I've cast it as an integer. So it's basically converting char C, or converting the character C into an integer of that same value. So if this is 0 as a character, this will be 0 as an integer. Okay, and again, how you figure that out is, well, how do I convert character to integer in Unity C#, in C# or Unity? And that's how you do it. And now, so that value is going to serve as an index for which I can reference in my mats array. And my mats array is just an array of materials. I'll redo this one. So mats. So I want to define an array of materials. So it's obviously an array of type material. Material. And it's an array. So that's the square brackets. And I'm going to call it mats with a Z this time, just so it's different. Okay. And now, so I've made this a serialized field. Hypothetically, you could have just made it public. So what I can do is now is assign this array values from the inspector. And you can see them here. Ordinarily, this would be 0. And then you would set this to be whatever size you want. So I'm going to set it to be 3. Okay. And now, what I'm going to do is just drag my materials and drop them in here. Now if you don't want this inspector panel to change from like off this, you can press the lock symbol at the top. And now if I click on other things like directed lights or main camera, you see this game manager didn't change. Okay, so now I can just drag and drop. I think we added the new one as 3, so I'll put 3 as element 0, and then 1 and 2. Okay, it doesn't matter like the order. I could even put 4 in here, but there was no 4. Actually, yeah, let's do that. I'll put 4. And then I'll make 0 the last one. And then I just need to change my text file to include 1 4 value. Cool. So that's how you can add arrays even like with the inspector, which is kind of nice. Mats doesn't exist. Yeah, it doesn't exist. That's correct. I need to save over here, I think. Why does this still think it should be mats with an S? Okay, I'll solve that problem in a second, but over here I'm just going to change these two to be 4 and 4. Sorry, 3 and 3. Because you remember we start indexing from 0. Go back to the inspector. That is strange. Okay, so the issue is that I didn't remove the reference over here to mats with an S. So I need to fix that to mats with a Z. Which then allows my inspector to update because there's no coding errors, and then this is over here, so that changed now to mats with a Z. It's kind of weird why it does it like that, but it is what it is. And now we'll just go 0, 1, 2, 3. That's good, that's good, that's good. Where are we going here? Cool. So now we have a way of getting a particular material based on the character. So let's just call this function. So we'll say material, so we'll define like a material variable and call it initial mat. And this is going to be, say, getMat, which is the function that we just defined. And that takes in a character. And that's the character that we want to reference is line array at x. Right? So this will be the current character that we're currently processing, just like we did it over here. Cool. So now we've got all these variables. We can define our world array, which is of type tile, right? So the world z comma x, and if you're confused, that's this guy here. So it's a 2D array of type tile. So world at zx is going to equal new tile2, okay? And then we start just giving it what it needs. We just give everything that it needs. So it needs an object, which is temp tile, comma, an integer variable for xval, and that is just x. An integer variable for zval, which is z, and our material, which is initial initiate mat. Boom. And that's all we have to do. So we create the object in the world. We then move it to the correct position. We then get what the material that we want is. We create a tile object, and you might be wondering, okay, well, where does the material change from the default? Well, remember in tile 2, we said that the mesh renderer.material is equal to m. So when it gets to here, that's when the actual material changes. Yeah. And now if I break over here, so I'll remove these breaks by just clicking on them again. Save everything, attach to Unity, go into Unity, hopefully there's no issues on this side, doesn't look like it, we run, and it broke over here, and I just run it one more time so that this line is actually executed. Now we can look inside this, which is everything like within this file, so to speak. We can go to world, which is our 2D tile2 array, and you can see it's tile2 of length 5 and 5, which is what we initialized over here. And we can then go, to world, and then now look at this. Okay, so we have here 0, 0, which is the first time this runs, which is the only time we've done it, and it's got a value of type tile2, which is exactly what we want to see, right? We have assigned it a tile2, and everything else is null because we haven't got there just yet. Okay, then you can see if I open this variable up, we can see everything that it contains, and it contains everything that you would see in tile2, right? It has the mesh renderer, the mesh renderer object that we wanted, and if you go base and then look for material, you can see it's got that 0 instance, which is the material that we fed it. There's also the tile, which is the tile game object, and it has all the things on that game object, like a collider and everything you would want or need. And in the XY positions, the XZ positions, which are 0 and 0. So if I run this until it gets to here, so I'll remove this and say continue. So now it's going to continue until it gets to the next one. You can see now all of these have now been updated with tile2 objects. And if I go inside them, they have everything like it's initialized like we want it to. Awesome. So what I can do now in Unity is look at my world that has been created, and it's exactly what we want. So things we can change here is if we go to that text file and we start messing around with the values. You can see there now, so we've changed the world basically. And then I run it again and it will be different. Cool. So this is how you can load in like different worlds, different maps from text files. But that's all we'll be doing for today, just to get you into classes a little bit, as well as reading from file, etc. Are there any questions? Cool. So I hope all you guys understood that, and like with the previous videos and stuff, I'll upload them to YouTube when to Moodle via YouTube when I get the chance, as well as the project itself.